I'm Andrew Regner. I'm a production engineer at Facebook working on the MySQL infrastructure team. That means that we are the engineers who, we don't write the code, we don't look at your data, we manage the infrastructure all around MySQL. And Facebook comes to these conferences a lot, talks about MySQL and what we do with it and all the awesome new innovations and stuff that we're coming up with. When other Facebook engineers come here and talk about what we do, we're usually talking about the Facebook graph and about all the massive scale of data store that we have around storing the actual data that you all assume that Facebook has stored in order to power the platform. I am not talking about that. I'm talking about everything else we do with MySQL. MySQL is the first data store at Facebook. For the longest time, it was the only real-time production quality, stable storage infrastructure. So if you had an application or a service, whether it's internal or external or whatever, you needed to store some data, you would put it in MySQL because that was the only choice you had. There's obviously other choices these days. We've heard about Barangay, which is a weird name that I'm just learning to call it by, but we call it ODS inside. We have all sorts of other data stores like ZippyDB, HBase Scribe, RocksDB, and many different flavors. But by and large, MySQL is still like the most mature, the most stable within Facebook. And so if you can point to any tool inside Facebook and there's MySQL being used in there somewhere. This all started, when we're planning this out, we have lots of different database tiers. I hate to use the word tier, but we'll split them up into different classifications depending on their size or whatever. The most generic of it, though, is what we call XDB, the anything database. And this is our equivalent of a multi-tenant shared MySQL hosting environment. We'll get into some more of the details later, but it's essentially the closest that we have internally to something like RDS, where a developer or an engineer inside the company can click a button or file a task to us and get some database resources. So this all started way back in the beginning when Facebook first started. We used to have something called CDB, the central database, which was just a DBA from my team long ago running some commands, like literally create database on a server somewhere in order to create a shard that he could then hand off to some other team to use for their product. That, of course, is fine for the beginning, but the company continues to grow. Now we're, the last public number I heard, is that? Okay. The last public number I heard for the size of number of employees at Facebook was somewhere around 14,000 employees. You can just imagine relatively small teams, divide that up into imagine how many different teams there are, how many different engineers there are, how many different products and services internally and externally there are. And obviously doing anything manual at this scale does not work. That said, though, the MySQL teams working on the infrastructure hasn't really grown equally in scale. We've added a few people here and there, people have come and gone, but there's still the same order of magnitude of engineers working on the MySQL infrastructure at Facebook. So that means that we've, of course, had to build all this automation. We've had to find out what our users are doing and find better ways to do it with less work from us. So to give you a sense of all the different use cases of MySQL that we could be talking about here, you've got all the different video encoding pipelines that we have whenever you upload a video to Instagram or Facebook or 360 videos or anything like that. It all goes through a queuing system to encode the different versions that you have, and that's all backed with MySQL. Our data warehouse has metadata, so it's all Hadoop and Hive and HBase and all these other big data technologies that I don't care to know about. And they're all the metadata to orchestrate all of that into different clusters is all MySQL. And it just keeps on going on. We've got internal tools all over the place. We've got hackathons. Like Facebook has internal hackathons many times a year, and every hackathon is guaranteed to produce another 8 or 20 or 30 or whatever XDBs. the visitor sign-in system, when you sign in to be a visitor to visit one of our campuses around the world, that goes into a MySQL database somewhere in an XDB. So it's just all over the place, which just goes to show that at this scale that we're at today, like I've only been at Facebook for a little under 2 years, and I will never know all the different use cases of MySQL, and I just have to accept that. I will only know the ones that have problems because they broke something and I have to tell them to fix it. Or I will know the ones who come to me ahead of time to find out what they're doing and advise them on how to do it correctly. So this also means that we've run into a lot of very similar problems that any other hosting company would have in building a shared multi-tenanted MySQL environment. But because we're an internal product for Facebook services, and we're dealing, our customers are other employees of the same company, that means that we can solve these problems in interesting and novel ways. But first, in order to understand all of this multi-tenancy and how it all works, we need to go through a little bit of terminology so we are all understanding where the co-location happens. So we start with a server. We're all on bare metal. We don't have any sort of VMs or anything like that. We just manage our own hardware. We have multiple instances of MySQL. In this example, there's 2 MySQL instances running on different ports. So it's just purely user local bin MySQLD running on different ports with different configs, pointing to different data directories and all that. On each of these instances, you can have shards or database schemas, whatever you want to call them. And these are completely unrelated. So, presumably this first instance here is one group of shards for one use case, and that customer owns the entire instance. And other instances, you have multiple shards from all over the place, all just crammed together because they're small enough and they don't need a whole instance on their own. So next, we'll abstract this concept of an instance into the larger picture and just imagine one of them connecting to some slaves. So we have a master. There's always at least one master and some number of slaves. We like to say that we have slaves for availability and latency and not for load balancing. We solve load balancing by sharding and putting it across more replicas, more masters, whatever. Given all the novel uses of MySQL in the company, that doesn't always work out, but that's what we do. So this whole concept of a master and some number of slaves, we call that a replica set. And it is thought of that these shards are hosted on a replica set because all instances in the replica set will have the same data, the same databases. So a shard is the ephemeral object on the replica set. The database schema is the directory and tables of that within an individual instance. So that means we're not doing anything fancy like per database replication. We're not doing anything complex. The theme to a lot of this is going to be how simple it is. So we can, as you saw earlier, you can have multiple databases on a single host. So a host that might be a slave for one replica set is a master for another. And then over here we can see there's another host which is newer, bigger hardware, and so maybe it has more instances on it. And it could have, another instance on there. It could be the master of a shared replica set. And so it's just, the point is that there's all sorts of different ways that this all works out. We intentionally don't care about how it works out. We just put instances on servers and we put shards on replica sets. And if everybody behaves, and everybody's doing the right thing, then it all works fine. The stories I'm going to get into is when people weren't behaving. A lot of times our customers are the other engineers at Facebook. I keep saying customers or users, but when I say that, I mean engineers at Facebook. They'll come to us and say, I've got this big product. It's really, really important, and Facebook.com will go down if this database is unavailable. I need dedicated hardware. We nod and grin and say, yes, sir, you're right. We'll make sure that you're highly available and we'll work this out for you. But no, you don't need dedicated hardware. Nobody gets dedicated hardware at Facebook. Everything at our scale here, we can't have the number of databases, the number of replica sets that we have, and buy an individual server for everybody's little database. And so we can grow the size of your instance. We can put you on a bigger instance so that you have a bigger chunk of the host or whatever, if that's what your workload needs. But nobody has dedicated hardware in Facebook. And that's something that We have to work with our fellow engineers on understanding that no matter what you do, no matter how important your product is, you can run a query that maybe you don't care that your instance was locked up while it was running that for an hour, but the guy next to you did. So this all feeds into the overall philosophy of Facebook infrastructure that, we have posters all over campus that say move fast and break things. I guess we're trying to less emphasize the break things part these days, but we still want to be able to move fast. We want our engineers to be able to build the products and the services that they need quickly. We want them to be able to prototype and iterate on it quickly. Want them to release early and often. So that means that the infrastructure that they need in order to do that can't slow them down. They need to be able to self-serve, to be able to create whatever resources they need to get going. They need to be able to see what's going on without having to bother us. Like I said, we're a small team, and there are thousands of employees all across the company working on this infrastructure. And so we're not going to be hiring hundreds of DBAs to support thousands of employees. We're going to have to find a way to do it with automation. And also, we are the DBAs. We're the people that know the most about MySQL in the company. They know the most about their product and what is important. So if they tell us we need to store a petabyte of data in order to support this product, then we find a way for them to scalably and efficiently store a petabyte of data. We don't have the time to even go into everybody's use case, let alone second guess them all to say, is this right? And so bringing that down to our own infrastructure on our team and the MySQL teams at Facebook, in building everything, we're still, even since 2004, still holding on to the philosophy that simple works. We've grown to be, as far as we know, the biggest MySQL deployment in the world because we keep everything very, very simple. You see very simple masters, very simple slaves. We just have a lot of them, that's all. We have a lot of orchestration around them to monitor them, make sure that they're all up and healthy and all that. But this also means that we're going to our users and saying, no, you can't use these features that, yes, you can look up in mysql.org and see that you can use if you download MySQL yourself. But here at Facebook, we can't run the infrastructure if you have these additional, if you're using these other things, because it complicates our infrastructure. It makes it hard to maintain. It makes backups difficult or impossible. It makes it difficult for us to replace instances or difficult for us to move shards from one replica to another in order to balance capacity and workload and all that sort of stuff. So some of the common things that we're having to tell users that, no, you can't use, things like triggers, views, foreign keys, replication lag. Like somebody might say, oh, it's fine to run this update query that's going to lag my databases. I don't even use the slaves. Those are just there for DR. I don't care. But we care. We care about lag. No matter what the user says, we care about the lag. And so we have to work with our users in order to find ways to put their application logic in their application and not in my database, or find ways for them to do responsible updates that don't lag the system. Find ways to help them with good indexing, find ways to help them plan for sharding. So if you say, I'm going to have a 900 gigabyte database today, but in 2 years it might be 300 terabytes, then, well, let's plan for next year. Let's not just put it onto a single shard now. So let's have some stories. These are obviously obscured to protect the guilty and also to illustrate the points that we're trying to illustrate, but they are all situations that have come up over the last number of months from me being on call on the team and dealing with users and dealing with the different ways that they find to break our infrastructure. And hopefully along the way we'll learn I will share with you what we have learned about what we can do better in the future as we're continuing to grow and continuing to scale and continuing to find new ways that our automation can save us time and keep the infrastructure more stable. So we're going to start with an engineer named Robert. He has a XDB called xdb.profileEvents, let's say. And let's say that the purpose of this is to store some metrics about people that choose to use a different profile frame over their profile photo for special events. So let's say that you have a profile photo and you want to commemorate your favorite sports team, for example. Go Spurs, go. Or you want to commemorate something that was really important and meaningful to you in your childhood. 50th anniversary of Star Trek. This is a little dated. The first time I gave this presentation, it was the 50th anniversary of Star Trek. So Robert here has a job that is going to look at the last 90 days, the times that people have activated a profile frame and for how long and for what event it was, and find out some useful information about how he can promote this feature that his team is working on. So he lands some configuration change to look at all of these records in his database of all the times that profile frame has been used. And everything is nothing in this shard is being used in production. It's all just back-end analytics. So it's fine. He just lands that and goes to lunch. It's okay, right? Sounds good? Well, no. Because what Robert didn't realize is that the platform that he's using to look at all these records is making, say, 20 different connections per record that it's going to be analyzing and inserting some more data about. And he has maxed out the connection limit on the host. So the host isn't able to accept any more connections. The connections that it does have are all running because they're all waiting on some lock for some row somewhere. Like, again, I don't understand the data because I'm not actually a DBA, I'm just not an automation engineer. But you've got all these hundreds or thousands of queries all spinning around waiting for the same lock. The scales here are adjusted for visibility, but the database isn't even doing enough updates in order to cause lag because it is wasting so much time on something else. And that has caused, you hit the connection limit, and that's the limit. MySQL isn't accepting more connections, and that means that all the other shards co-located with Robert can no longer do anything. And then maybe there was an important shard next to him that actually did care about uptime. So that's not good. This is all caused because Robert didn't understand the entire stack underneath him. He thought that, for each record in database, do processing, insert results is just completely fine and naive to use. Because, he's a front-end engineer, let's say. He doesn't understand data models or databases at all. So this is a common problem that we see in different versions all over the place, that you have an engineer that is just doing their job and they don't understand all the abstractions that they're sitting on top of. And so it's either the responsibility of all those abstractions to limit them from doing something that's going to break infrastructure, or to teach everybody. We're adding more engineers and I can give tech talks, so we have to go with the former. But for this situation, it caused a bad day for a bunch of people. In debugging it in this situation, all of our queries that actually make it to the server have query comments from where in the code base they came from, what job or service it was that was sending the query. So we can use that in show process list and find out who to send a page to and which job to kill, and tell them not to do that again. My next example here is about a ticketing system. So every time that some ticket created in the help center is changed status or changed queues or whatever on the back end, it creates some metadata. And sometimes these help center tickets are about sensitive things about, I want to change my name, or this person hacked my account, or whatever. And so there's legal mumbo jumbo around it. Again, just an automation engineer. So for whatever reason, we have to hold on to this data forever. And this was a hackathon project from 8 years ago to hold on to this data and to create a schema around the back-end metadata about help center tickets or whatever. And so it was just built, it worked, it kept working for many years. You're just adding a few little bytes every now and then, it's okay. Usually when you see a graph like this, it's not going to have a happy ending, right? No. So I obviously can't give you exact numbers here, but this is where the alarm went off to say that the host is almost out of disk space. And that is the maximum capacity of the host. So this is like the last few days leading up to the death of this shard, but this was a situation where our automation was really, really good at hiding the problems and helping the infrastructure to continue to be healthy. We have automation that, if you have multiple instances on a host, if one of those keeps growing and growing and growing, and the automation will see, oh, look, your host is almost out of disk space. I'm going to move one of these smaller instances away and put it onto a spare host that has more space on it to let this bigger one keep growing and growing. And so if you just extend that out into the future, then that means that your instance can just grow up until it is can't grow anymore. Like, we literally can't move anything else because it's just one shard on one instance. There's nothing else to split. So in this situation, it was a panic to, page to the people that own this help center tool, get them to find some data that they can delete, get them to move some other data to some other system for retention purposes, and just get it out of live MySQL instances. Lots of meetings, lots of talks, lots of planning around how to do this. It was a pain in the butt. But the best way to get around this, though, is going to be just better guidance. We have a wiki with the ideal shard sizes and plan for your shards to be this many gigabytes or whatever. But for a help center tool that was started in 2008, that wiki didn't exist back then. So we've got a lot of legacy shards. Of course, ironically, the legacy ones are always the most important ones because they're the ones that have been working so well for so long and nobody remembers. So that means that as hard as we can try to teach new engineers the right way to build a new system or to use MySQL, that still means that we have to find the ones that are not using it correctly now or don't even know that they aren't. The solution to this ended up being we have a tool that a former intern wrote that is now a full-time employee that can give it some arbitrary SQL statement, and it will delete records that match that over time in chunks in order to not cause lag. So we ran that, and 4 weeks later, the shard was small enough to actually be manageable again. And then, of course, since deleting doesn't actually reclaim space on disk, we used our OSC, our online schema change tool, in order to just rebuild the tables in place so that you can actually now have that space on the host again. As I mentioned, our automation was really good at hiding all of this from us. Our longer-term roadmaps is we're planning on we're now at the point now where our automation can see some of the more obvious growth patterns. You can all imagine all sorts of different ways that you can be loading data into MySQL and not ever realize that you're about to run out of disk space. But straight and up and to the left for the last 30 days with no end in sight is probably a pretty good sign of bad growth, or going from 200 megabytes to a terabyte on disk or whatever is also probably a bad sign. So there's some obvious cases which can catch most of these sort of things. We can have automation automatically paging people and stuff like that. But that's not going to, we're still going to have situations like this on into the future because you can never define the perfect heuristic for what dangerous growth looks like. My next example here deals with replication lag. So everybody knows about what causes replication lag. It's a very common problem. We see, I've lost count of how many different ways I've seen replication lag happen inside Facebook. This is just one example. I actually literally took the data for this from something that was lagging this morning. There's always something lagging. Like I mentioned, we have really small replica sets. We're not talking hundreds of servers, hundreds of instances of your data set, because again, we don't want to buy that much storage. So if you have your entire replica set, let's say 5 instances of it are all lagging, then that means that there's only one live copy of your data, and that's bad. if anything happens to that master, if there's a solar flare and it takes out a data center or something, like your data is gone, and that is the absolute last thing that we want to have. So lag means you are no longer highly available. You can't fail over to a lagging slave because then you lose data, stuff like that. So this is about a very vaguely named shard, xdb.analytics. There's a lot of companies at analytics that do data. There's a lot of teams at Facebook that do analytics, if you didn't know. So some engineer somewhere, he wants to clean up, or she, I don't know if it's he or she, I don't know them. They want to clean up some data on their shard. Maybe they added a new column, maybe they're preparing a new table to be used in their production application. So they just run this little query, delete from some table where its ID is in this subquery select foreign key from where random thing is equal to something else. So that's either like a really handy, really quick, nice atomic way to delete data based on a foreign key, or that's a really very quick way to cause a problem in your replica set. Can anybody guess which one this is going to be? Yeah, it's the bad one. So you can tell where that statement hit the slaves. That little bits of lag before it, like maybe that was the master running out of resources to give bin logs to the slaves fast enough or something like that while it was executing that delete query on its own. So anyways, this is statement-based replication, so that query hits the slaves and they all start lagging linearly, nice and lockstep with each other. This is where our automation disables the slaves from our service discovery system so that clients aren't getting bad data. So this means that not only are all of your slaves lost or stuck back in time and no longer have the most recent data, and so you're at a single point of failure now, but also now all of the production traffic for this entire replica set is going to that one instance, so the one master. So, I understand the reasons why we do it, but it's sort of a double whammy that you now have a single point of failure, and now that single point of failure is taking on more traffic because the slaves are no longer considered reliable while they are working on computing this query and catching up. And so, of course, because of all this multi-tenancy going on, each of the hosts that all the slaves are on are under different loads because there's different instances for different workloads on them all. So they all catch up, the same shape, but in different patterns and different times with each other. So at the time that I took this graph, 2 of the slaves were still lagging because they hadn't caught up yet. So our only response when this one bad query comes in and destroys everything, our only response to it is to page the person that did it and say, don't do that again. If it feels sort of lame, but that's what we can do. If it gets really bad, the slaves are just lagged out all to death and there's no more bin logs or whatever, and so then at that point we have to replace this in instances, and so it just takes longer. Or sometimes our copy and replacement process for an instance is actually quicker than waiting for them to catch up in bin logs. So that's a judgment call that we can make. If we catch it early enough, we can kill that bad query on the master, and that's actually one of our longer-term plans is to have automation. We have a feature in our branch of MySQL that adds up the amount of time a running transaction has added or has done so far in a given connection. So our automation can run this one little query on an information schema table, and we can see this connection has been processing its current transaction for the last 300 seconds. It's probably going to cause some lag. We can just kill it now. So it'll get rolled back. We'll send a page to the person that just ran that query saying your query was killed because you were doing wrong things, and it'll never cause lag in the first place. So that'll be cool once we can do that. I think this is my last example here. I call it the nicest bad neighbor ever because neither shard here is really at fault. It's just a matter of bad co-location, bad timing. But I thought it was sort of interesting. I learned a lot about MySQL internals when this happened too. So we have a shared pool of XDB shards. Those little multicolored instances I mentioned, those are what we call the shared pool, or when we don't like them so much, we call them gen pop, like they're all in jail with each other. So we they're predominantly shards where only one person or one thing cares about them, and it's not really that important, and it's definitely not something like production Facebook.com scale or important for that type of a thing. It's usually like somebody's little tool here, or some little back-end process here, or something like that. Oftentimes it's even like somebody made a shard and then it became important a year later and they didn't realize that they're still in the shared pool. Anyways though, it just means that we've got a lot of different use cases all in the same replica set even, not even just the same hosts. So we have, in this example, we have one shard, we'll call it xdb.scheduler, which has a queue type of workload, a lot of really small queries that are really quick, supposed to be really quick. And an archival shard, we'll call it xdb.lookslike. So it's archiving data about maybe some vision system or whatever, some machine learning thing saying that this picture looks like that picture or something like that. So this story starts in the middle of the night when a backup starts. You can guess when the backup starts. So our backups are logical MySQL dumps and taken inside of a single transaction per database. So when the system started to back up the looks like shard, it started a transaction, and then of course InnoDB, doing what InnoDB does best, it has to maintain, I think you guys call it MVCC, multi-version concurrency control, yeah. It has to maintain that state of what has changed for this backup and for all the data going forward as the backup is running. It's a very, very big shard, so the backup takes a really long time. Even using table compression, so like we're reading for every 1 gigabyte you're reading off of InnoDB, you're actually writing a 10 gig SQL file or something. So that backup took many, many hours, and as that progressed, these little tiny queries going into the scheduler shard just took longer and longer as every single little select for update or insert or update this locked row query or whatever has to scan the entire history list in order to see if there's anything that applies to this scheduler shard. Now, of course, there wasn't, because most of the updates coming into the replica set were for something else, but this history list was getting bigger and bigger by the hour. And then at some point right here is when the scheduling system just like completely tanks and can't do anything productive at all anymore. And then we get a page, I get a page because I was on call at the time saying, what's wrong? I'm just doing these tiny little queries. And I say, I don't know, there's nothing wrong. We're just running backups. That's what we do every day. So we killed the backup because we didn't need it right now as much as we needed to keep the site up. And so history list is purged. Everything's happy again. The solution to this currently is to just take one or the other of these and put them on their own replica set, and then just hope that automation doesn't rebalance them back onto each other. In the longer term, we already ask our users in the UI that they use to create shards what type of a workload, like is it OLTP, OLAP, or both, or whatever. But to be able to start using that, because we have enough shards now that we can still efficiently balance and co-locate shards and instances with each other that all have similar workloads. In the beginning, when XDB first started, there were only a handful, a proverbial Facebook handful, so a few hundred shards. So it wouldn't have been efficient to be splitting them up based on workloads like that too, because then we'd have a lot of wasted hardware. But that's not the case anymore, so we can revisit that. Lastly, I want to go through a few highlights of some interesting tools that we have in order to deal with operational challenges of multi-tenanted MySQL. So replication lag, obviously a big problem. We see lag so often that we now have a tool that looks for it. So as soon as a slave gets disabled for lagging, it also runs this report, just runs show process list and normalizes some queries enough over 30 seconds. And then gives you a count of how many times each different query pattern showed up. And so in this case, there was a load data in file that was running under this one database. And it saw that query over 2,000 times. So that's what was causing the lag at the time that this slave was disabled. And so we can just take this to the owner of that shard and say, don't do this, you're causing lag. And extending that, we even now have a command line tool that will send a UBN, which is our internal task page thing, wake somebody up to say that they're doing something wrong. So once we identify that it was this shard doing something wrong relating to either size or lag or query volume or whatever, you just type in the name of the shard, the general classification of the problem, size or lag or whatever, and it pulls some data from either ODS, which is our time series metric system, or from that query REPL plane that you saw before, and it says, here's what we found, this is a problem, here's a link to a wiki and how to solve it. And it still requires our on-call to run this command and find who is doing it so you can know who to point it to, but the metadata for who owns a different shard and who their on-call is and all that sort of stuff, that's all tracked by the XDB automation. So it's pretty quick. We've gotten what used to be years ago, used to be hours of troubleshooting possibly in order to find the problem, to help find the person responsible for it, help them solve it, down to a few minutes or a minute or two of troubleshooting and then a single CLI command. We also, I talked about self-service interfaces. So being a company with with a fairly big website, we also have a lot of internal tools in the browser. So we have a DB portal, we call it, where you can put in your shard or your database instance or whatever and see a lot of information about its current statistics. You've got links to different charts and different metrics about your individual tables and stuff like that. This is an actual shard. It's one of our testing ones. So we have a little potato farm of testing shards. It's obviously no problems detected. So everything's OK with this one right now. That usually just means that one of us isn't testing anything right now. You can click around through here and get more information about running queries or what connections are coming from where and stuff like that. And so this is a thing that our users use a lot in order to help. Once we give them a task or a page saying this is broken, go fix it, they can use this to find out where that's coming from. Because again, we don't know their data, we don't know their application. We just know that there's something bad happening. Speaking of something bad happening, so this is a replica set that doesn't look so good. It is all of its slaves have been disabled for lag, and so you can see the seconds behind master for each of those instances on the side, and they can click on the number of running queries and find out what those slaves are doing, see what the slaves are working on applying. And also, whenever anything is written to the slow query log in MySQL, it gets written into our central logging infrastructure we have. And so the DB portal itself can query this and say, show me the slow logs for the last 2 hours for every instance in this replica set. And then, if the shard owner recognizes one of their tables or one of their databases in the list of slow queries, then they say, oh, look, that's probably a problem. And they can be that much closer to a solution. Looking ahead, I've already mentioned a few things about what we're looking at doing and trying to improve, about automatically killing bad queries or automatically finding bigger shards before they get too big. But that's predominantly what I and a lot of other people on my team are working on these days, is looking at, spend some time in the trenches, find out what we're spending a lot of time fixing, remediating, helping users with, and then building that into infrastructure so that we don't have to do it again. Because, I've been at Facebook long enough now to know that what I have done last year, what I had to do 3 times last year, I've had to do already 7 times this year, and we're not even over with this year yet. So it'll just get worse. And so we have to build the automation around this, and I've worked at hosting companies before, so I know how the hosting company methodology goes about it. And you isolate your users, you put limits on things, you make them just pay more to use money as an incentive, but like none of those solutions work at Facebook when your customers are internal and they're also your coworkers. So, but that also means though that you can come up with more interesting solutions saying like, you know, your product is using this much resources, why? Or, you know, we have everybody's cell phone number, we can page them really quickly, and that's helpful too. So that's all I've got, and thank you. Any questions? I don't know how much time I have left. Yes?
Regarding mapping shards in individual products, is there always a way to like and if so, how do you manage consistency across shards in terms of defining data types, how you store currency?
Okay, so the question was about how mapping a shard to an individual product or an owner, I assume you're getting at, and how do we manage the consistency of that going forward. So that is the biggest unique defining feature of XDB versus all the other DBs that we have at Facebook. So XDB is just like all the other databases, systems, tiers at Facebook, except that there's metadata about who owns what shard and who owns a given dedicated replica set if they're big enough to have that. So everything, you know, every team at Facebook does like an internal, you know, just like your Facebook profile has an identifying number, an FBID, like every team has an FBID, so we can record that. Every on-call rotation also has an FBID, so we record that. Through the DB portal, they can manage their own shards and say, you know, even if some part of Facebook reorganizes and teams change, they can update the ownership of that, and we can even see who used to be on this team. And if it gets really hard, like we can say who used to be on this team, who used to be in this on-call rotation that is now deprecated, and find somebody to send a task to in order to get them to both fix the problem and update the metadata. As I alluded to, there's a lot of legacy stuff that we're still also dealing with because, you know, XDB hasn't existed forever. And we've only been enforcing requirements on you have to have a team that owns this and not just some intern. And so that is something that a lot of our older shards don't have proper metadata. And so like when I get bored, I start scrolling through unowned shards and Facebook org charts in order to find who owns it and get them to take responsibility. But like we have, even on the legacy ones, we have enough data that we can make an educated guess when a critical situation happens of who to send a page to, because they may not own it, they may not own the application that is hammering the shard or whatever, but they probably know somebody who knows somebody who does. So, you know, social networking. Imagine that Facebook's good at social networking.
What version of MySQL do you run, and how do you manage that, different versions?
So the question was what version of MySQL we run. Our current production branch is based on 5.6.37 or something like that. It's FB MySQL server. So if you go to github.com/Facebook/FB MySQL server, you'll see all of our production code. And our MySQL engineering team iterates on that pretty quickly, and we get a new RPM release out, let's say once a month. That's probably undercutting them a bit, but our automation manages MySQL versions, so we know that like this replica set is on this version, and if we're replacing an instance, we need to make sure that the instance it's being replaced with is also at that version before data starts to be copied to it and stuff like that. We upgrade the fleet fast enough that we don't need to worry too much about, you know, too many old versions or whatever like that. Like they're all based on a version from like the last few months, like out of every server and in all of Facebook. And with very, very few exceptions, the individual users don't know or care what version of MySQLD that they're running. Some of our bigger users that are using some new features that MySQL engineering has literally written for them, like they will care. And so like they'll be pinging me saying, you know, are my instances upgraded yet? Is my shard map upgraded to this new version that was released yesterday yet? And I say, no, I'm at Percona still. I haven't ran the upgrader yet. There's another one. Yeah.
So it looks like you mostly put a big emphasis on like capacity planning for right sizing, like where a shard should go, how much space you expect it to use, but and like in the case that it's growing a lot faster than you expect, like you kind of page the owner, but what kind of recourse do you have if it has to be like resharded?
So resharding is a very difficult thing. Spoilers. So by maybe more than 90% of our different shards across all of Facebook are space constrained. So like our servers are fast enough, we're replacing hardware generations fast enough that in the end it just comes down to disk space, and we balance replica sets and instances and shards based on disk space that they're using. That's changing now as CPUs are growing slower than flash cards are. But when it comes to sending involving one of our customers because their shard has gotten too big, oftentimes, like 9 times out of 10, it has gotten too big because of a bug in their system, or because they didn't realize that they were still storing this, or because they didn't realize that they forgot to put retention on this table or whatever. Like we have automation around partition management. So like all it takes is somebody to write a little config and land a small little diff to say that this table should only have partitions this big and drop the most and only retain these many of them or whatever like that. So like we make that really easy for our users to do partitioning. If they really do need to reshard, a lot of times the data that they're storing in MySQL is coming from some other system like Hive, and so they can just backfill everything that, I have seen teams reshard into multi-shard deployments and just backfill all the new shards with data from Hive and then switch over, and it's fine. Other times teams have actually spent months rewriting and doing data migrations and double writing and stuff like that, and like it all just comes down to the engineering effort that they're willing to invest in fixing the infrastructure. And if they say to me that it's too much work to reshard and we need all of this data, then I say, okay, well, your server is going to fill up on this date, and in order to protect the server so that I can still log into it, I'm going to turn off your shard on this day. And then that day arrives and their shard is off, and then they spontaneously have time to fix it. So it's okay. Any other questions? Yes.
Just a follow on to that. So if a shard is growing and needs attention, how often is that handled by automation, just moving it to different instances versus a human getting alerted and having to deal with it?
So the automation moving shards between replica sets or moving an instance off of a host in order to allow another instance to continue growing, that is happening more times than I can count every day, all the time.
Okay, so you just have some thresholds where if it's growing this fast, we need to page the team and have them actually look at what's going on.
So the amount of times that a human needs to be involved is, I like to call it rare, but rare at 2017 Facebook scale still means like multiple times a month, which is problematic for a small team of, what are we, 7, 8 people now on one rotation. So yeah, like every time you're on call, you'll see at least one of these, which is too many in my opinion. But the automation moving things around in order to prevent it is happening a lot, and I, by design, don't know.
How about row versus statement replication? Why did you choose statement, or is that
So I don't know the original reasons why. So long ago, almost all MySQL replication at Facebook was statement-based. We now have a combination. A lot of things are using row-based replication now. In the XDB world, statement is still the default. For, I don't know, smarter people than me can debate if this multi-tenanted use case is better done with row-based. But we have a lot of customers that intentionally are set to row-based replication for their dedicated replica sets, and that works great for them because they're running, horrible delete queries like that or something like that, and that will replicate nicely in row-based. Right. If that horrible delete query that I showed shows up in an RBR bin log somewhere, like that one bin log could be 80 gigabytes or something for all we know, and that would be bad. And in that case, I would either rather automation kill the query, or I'd rather it go through statement base and kill the slaves, and then we get a page and have to fix things, instead of filling up the bin log partition. One last question? Okay, so the question is, what is user experience when we move a shard? And usually nothing. We have automation called OLMs, online shard migrations, that lets us dump an atomic view of the entire shard into a destination, to all the destination instances of our replica set. Use the bin logs on the source master to replay and catch up the destination instances for all the updates that have happened since that dump was taken. And then we put the shard on its source into read-only mode for a second or two as we do a final catch-up, and then update service discovery to point to the new replica set. So if a very, very attentive, very close user was watching it like a hawk, they might notice a second or two of downtime, but all of our clients are designed to reconnect when you hit a read-only master and stuff like that. So usually 99 times out of 100, you don't notice anything when a shard moves. Great. If you have any other questions, ask me or any other Facebook person at the MySQL booth, and go play with my rocks. Yay.